All right, so how do we utilize all this in an example? Well, let's say that you're standing 80 meters away from some kind of speaker. It's projecting some kind of tone at 300 hertz. And you realize that if you have a remote, you click play. It takes about 0.24 seconds for you to hear the sound once you hit that button and turn that machine on. So we want to know two things. What is the wave speed of the sound waves, and what is the wavelength based on this scenario? So to find the wave speed, we actually don't even have to use the wave speed equation. This is a much more straightforward speed equals distance over time. We know that the wave has to travel 80 meters, and we know it's going to take 0.24 seconds. So this, I think, literally might have been the first equation we dealt with in the course all year. Anytime you know the distance something has to travel and you know the time it takes to travel that, you can quite simply figure out its speed. So this sound is traveling at about 333.33 meters per second. It's close to the average of about 340 that we would expect through air. So we know that we've most likely done this correctly. Now that we have the speed of that wave, now we can go ahead and we can use the wave speed equation to find the wavelength. So the speed we determined in the first part was 333.33 meters per second. We're told that the frequency is 300 hertz. So therefore we can simply just solve for the wavelength, and the wavelength of these individual sound waves must be 1.1 meters. 1.11 meters, I apologize. Now I'm going to throw this one at you, which you didn't expect, but if the frequency was increased to 500 hertz and you stayed exactly where you were, same situation, we're just increasing the frequency, what will happen to the wave speed and what will happen to the frequency? So think about it for a second, and let's see if we can figure this out. So the first thing to notice is when it was 300 hertz, the medium that the sound was traveling through was air. When the frequency is 500 hertz, the medium is air. The medium has not changed, therefore the speed doesn't change. It's still going to be 333.33 meters per second. The only thing that changes the wave speed is the medium. So what will happen then to the wavelength? Well, now we can use our wave speed equation. The speed is still 333.33 because it's the same medium, but now my frequency is 500. And when I solve this, I'll find that my new wavelength is now 0.66 meters. Frequency and wavelength within the same medium have an inverse relationship. If the frequency increases from 300 to 500, then the wavelength is going to decrease from 1.11 down to 0.66. And that is simply because we are still in the same medium. It doesn't matter what I do to frequency or wavelength. The wave speed will not change unless I go into another type of gas or a liquid or a solid. That is the only way wave speed will change.